For a while now, we've been using ingestible electronics, things like monitors, cardiac pacemakers. These miniaturized devices that they had like biocompatible enclosures. They used to kind of basically place inside your body. Uh, Not all of them were swallowed. Some of them, I guess, were surgically placed there, and then you had some things that were kind of like attached to you. Now there are researchers going into more advanced procedures as far as edible electronics and things that can be exited out when we go to the bathroom, and maybe these things help to monitor the activity in your body, or maybe help find a solution to a particular type of illness or complication. I want to look at research two different research projects, I guess I could say. One is basically done by or conducted by Italian researchers, and they wanted to have like an alternative type of ingestible electronics, stuff that can kind of be more environmentally digestible, I guess, or environmentally friendly. I guess once it's done, it's what it has to do. Now, these researchers have what they call edible generators and capacitors. They're made out of food grade ingredients that can safely be ingested, and they degrade in the body after completing what they have to do, as I mentioned earlier. And so with this type of project, they have what they have a series of electrically conducive composites, and they only use two materials. The first is ethyl cellulose. It's like a sugar or like a food additive. It's kind of like a derivative of cellulose. In the food industry, it's known as E462. The second material is activated carbon, E153. It's an additive with like a smoky taste, and they say it's pretty stable in the digestive system, and it can be exited out when you take a dump, or in their words, excreted with feces, of course. So anyway, so the way they make this is they take just different quantities of this activated carbon, and they kind of disperse it in a solution of the ethyl cellulose. They kind of mix it up in that solution in ethanol, and this mix can be thrown in a petri dish, and ethanol is like allowed to evaporate. The process also includes gravity-induced phase separation. It's generated by a series of films with opposite faces, showing completely different electrical properties. They have a conducive bottom layer and a binder, which is the top layer. They also added edible additives like myristic acid and sunflower oil. Both of these act like plasticizers. They plasticize the ethyl cellulose. And when they were running the tests, they put these materials, once they've already binded them together, they put them in immersed, kind of simulated gastric fluid, kind of similar to what's in your stomach. They put it there for around 3 days, 72 hours, and they all found to be mechanically and electrically stable. Which sounds, I guess that sounds pretty progressive. And I'm wondering, okay, it's mechanically and electrically stable, but that's a simulation of gastric fluid. Now I'm wondering, I didn't read anywhere where they had a human test, and I wonder, or I don't want to say human test. Sorry, I guess they got to go to the mouse first. The mice. They got to go to the mice first. So I haven't seen anything where they went to the mice first. I'm guessing that may be the next phase. I don't know. I'd be interested in finding research in that. I might look that up later. So without getting too complicated, it was almost like they made a fully edible supercapacitor, which is interesting. So you're eating an electronic supercapacitor that can be digested and exit out when you take a dump and flushed, or maybe it's collected for something else. I don't know. Right now, it looks like they're just in this research phase, right? Which it looks promising. I guess they could use this for certain things. I'm also thinking there's some bad things people could use this for. I mean, imagine mean, my mind's running. I don't want to throw any ideas out there. I don't want to say what I'm thinking. I'm always thinking, what could be the dangerous parts. I don't want to think that. But I think this is good as far as maybe monitoring what happens in your body. Maybe this is a good way to check your colon without getting poked or, putting something up there, right? You could just take one of these small electric capacitors and maybe have a little camera in it, and it runs through your system. Maybe it can be controlled to stay there for a couple of hours. It runs through your system. You don't feel much. And then you have something to eat and you send it out. And somebody takes it, right? And study the results. Honestly, that would be a good use for me. And I think that would be a lot better than what happens now when people's colons are checked. Or I'm sure there's other uses. Maybe something so small that could analyze your blood vessels, your blood sugar. Right, goes in your body temporarily. Maybe you sneeze it out, you cough it out. Other things, exit other ways. Right, I'm sure they can come up with safer ways for this. These small electronic generators, capacitors, to pass through your body and provide information. And it's really small. And they soak it. I forgot to mention. Sorry. They actually also wrap this in seaweed. Okay, there you go. And it's like I guess seaweed's also a current collector, right? Collects electric current, and it's soaked in electrolyte. So yeah, it makes it edible. It makes it generate power for itself, and you put this in your body and whatever purpose they have for it. I think it's a great idea. There's another research project where they used something a bit more environmentally friendly, according to these researchers. I think this is in Sussex, UK. The other one I just mentioned was Italy. But this one is where they use natural elements like rock, salt, water, and seaweed again. They also combine it with graphene. And I've seen graphene used in everything. They say it's a great conductor, it's cheap, it's light, it can be strong. They seem to be using graphene in everything, even when building AI, as far as the hardware is concerned. I remember I actually saw a whole write-up in a whole project. I don't want to get caught up, talking about graphene. But anyway, I'm going to get away from that. I can do a whole other video on graphene. But this is another edible electronic device where, again, it's made up of, as I mentioned, seaweed, graphene, rock salt, and water. And they say these more natural elements that they just put together, they outperform the devices that are out there now, where people use synthetic-based hydrogels and nanometers in health monitors and different types of, I guess, what do you call it, health monitors and things it doesn't say, some type of sensor, basically. The sensors they use today and the monitors they use today have hydrogels and nanomaterials. So they say that this seaweed and rock and salt is much better than the synthetic material used, which are these hydrogels and nanometers. I'm trying not to get it too complicated. I'm trying not to get it mixed up because I don't like for things to sound overly complicated myself. Hopefully I'm not doing that. If I'm doing that, I'm sorry. Please forgive me. I'm trying. So the idea here is they use seaweed in a health monitoring device, just like in the other project, and they use the seaweed combined. I guess they put it around rock salt and water. And the way one of the scientists discovered this, he was actually watching a cooking channel. And on the cooking channel, he said he saw how they use seaweed to thicken desserts and give them a soft, bouncy structure. And it was some type of vegan episode he was watching. So a researcher watching a vegan episode inspired him to make an edible electronic. This is an interesting story in itself. It's like an interesting side story. So yeah, you have a scientist watching a vegan cooking show, vegan cooking episode. He's inspired to make electronics that are edible, right? He says it's good for the environment because with the sensors they use now, it's like it reduces the mass production of rubber and plastic that they use now in health technology, and kind of, and those things aren't exactly healthy for the human body, and they kind of pose a health risk, and they kind of leach onto the water we drink and that type of thing. So this is like a better alternative. But why? I mean, I'm wondering, if we knew certain foods were electronically conducive before, why didn't we use those? Why nobody thought to use this if this was known a long time ago? Or I don't know. I don't think it's just now known. At least I would think. We have a chart. We learn in school. I can't remember it, where it's what's conducive for electricity and what's not. So anyway, so with this project, the seaweed is the insulator, and they add like a significant amount of graphene to a seaweed mixture, and then they're able to create an electronically conducive film. Okay, and they soak this in a salt bath, and the film absorbs the water, and it results in like a soft, spongy, electrically conducive hydrogel. Okay, that sounds a bit natural. Even though that graphene thing, I don't want to get off topic. Again, that's a whole other video, but I'm gonna stick to topic. I'm gonna stick to the main topic. Sorry. So they say this has the potential to revolutionize health monitoring technology and future applications of clinical grade wearable sensors. They could look something like a tattoo. That's a good idea, actually. So you're kind of putting more natural things on your skin to monitor things in your body. This is not a bad idea either. It's not a bad idea at all. Right? This is kind of like a healthy tattoo, right? So it's like you're going to the doctor, you can get a healthy tattoo. Now I'm trying to think. Just like I mentioned before, what could this be used for? I mean, I guess it depends, right? You can just put the tattoo in one spot the whole time, and you could do a myriad of things, right? Again, monitor your heart rate, monitor what you're eating, monitor if you're getting the right vitamins and minerals, and that type of thing. That's not bad, actually. It's yeah, I could see this going a lot of ways too, right? Who knows? This is getting really futuristic because, I mean, if this is like wearable electronics, what kind of things could you put in there? What kind of circuits could you put in there? You could actually put AI in there because, again, you're a conductor yourself. Your body's an electrical conductor itself, right? So this could, bind to your body and continuously provide energy as long as you're breathing to this material. And you could wear this, it's not just for health, but I'm just thinking other things like gaming and how people interface with their computer, how people open their door. This is almost getting into, I'm getting off topic too much, sorry, but I'm just thinking because this is like a tattoo. Imagine, we've seen the movies, so there's so many things you could do with this, or so many directions you can go outside of health, but there's so many benefits, and I'm trying to stay focused on the benefits. I know we could all think about the dangers if only we were all so ethical and righteous, but unfortunately we're gonna have to build in some fail safes for this. Maybe there's a way to turn it off, of course, but this is amazing. It sounds really sci-fi, and I'm looking forward to see how this kind of pans out and develops. I'm sure there's going to be people who are going to like think of ways to track their kids and their dogs with this new tattoo, or this new, they call it new skin. Anyway, I could ramble and ramble and ramble, but let me know what you think, and thank you again so much for listening.